What up, party peeps? Today we're talking from Natalie. She is from the future. Technically, she's in Australia, so she was actually a day ahead of us here in the United States. Kind of a wild time. But we talked about neurotechnology. Her device and the company she runs is called Neurode. They are a brain measurement and a brain stimulation company. And we get really deep into the science in this episode and really grill her on some of the claims they make on their website. I'm not gonna give it away, but I was impressed with some of her answers. And by the very end in the lab results section, Chloe and I decided that if you want to try Neurode, we think
All right. Hello, everyone. Welcome back to the Decision Lab podcast. Today we have Nathalie Gouailhardou. She is the founder of Neurode. Welcome, Natalie.
Hey, excited.
woman, the myth, the legend, coming to
We're
us.
all spread out across the globe right now.
Dude, for real, she's in the future for me, technically.
Yeah, one day ahead, living in the future.
Where are you out of? Where are you coming out of?
Sydney, Australia.
Boom. Love
Down
to hear
south,
it.
other side of the world. Yeah.
It's a wild time down there, I've heard. We've talked to a couple people from Australia, and it's always at wild times. I love it, though. Tell us a little about you, though. I'd love to understand how you got here. Tell us how you kind of became the person you are today.
Oh, easy question to start. Yeah, I mean, I have so many like threads to pull right now. I guess I was born in South Africa and immigrated to Australia when I was pretty young. My family were really, really like really valued education and we're like here to study hard and have like the best life because that's why we moved to this country. And so I think the immigrant mentality was pretty like formative for me and like being really interested in school and studying a lot, but also got diagnosed with ADHD when I was 5. So I was like, one side that's like you have to study really hard and do really well in school, and then I was an ADHD kid being like, ah. But yeah, I think I always really liked school. But at 5 years old, they noticed I had ADHD, which is pretty rare, I think, for a woman and or a little girl. And I think it was because I was just so like spaced out and in my own world that the teacher would call on me and I just wouldn't even respond because I hadn't even like registered or heard them. And so at first they thought might be deaf. Like they checked my hearing, they checked my eyesight. They were like, this girl can't hear. And I was like, no, she's heard me before. Like she can. And so they did a whole bunch of testing and finally realized, oh no, she's not deaf, she's not blind, she can like do everything. She just has ADHD and isn't paying attention, and that's why she can't hear us. And so, yeah, I guess got diagnosed at 5. And I think like my parents just wanted to do the best thing for me. So they were researching, taking me to different doctors. I tried different medications. That didn't really work out for me. I was always feeling sick, having my appetite affected. And so they even tried like taking me to a doctor that made me, and this is why, like, honestly, science education is so important because my immigrant parents just wanted to do the best for me, but they did not know like how to evaluate things. So I went to a doctor who was making me follow a ball with my eyes for like hours on end every Sunday on my weekend to improve my focus, and it's like a non-drug way to treat ADHD. So I tried everything. Fast forward to like high school. I, by that point, like stopped taking meds and was kind of trying to figure it out on my own for how to study and do well at school. And pretty luckily, I was always really interested in school. And I think that's one of the like ADHD benefits of like being interest driven. So I was always interested in science and biology and a lot English, a lot of my classes. So I was actually doing okay at school, which meant that, you know, I got to go to university. I was kind of nerdy. I was like, and I think, yeah, by the time I finished school, the kind of questions I wanted to answer were so much around like, why are people the way they are and things like that. And so I found myself studying at first sociology and anthropology, being like, I'm going to understand people.
Hey.
It's like, I love people. And then I was like, oh, this isn't what I think it is. And so then I moved to psychology. I was like, no, I'm thinking more like how our minds work, not like how society is formed, which is like a kind of like an aggregate of people. But so then I moved to psychology and I was like, oh, this is more like it. But I want to like know more and get deeper into what's actually going on here. And so finally changed degree again into neuroscience, and I was like, okay, this is a sweet spot. And so yeah, like a lot of the questions I wanted to understand were definitely about like why we are the way we are, but what I ended up kind of realizing is that so much of our ability to understand the brain is limited by the tools with which we have to measure it, because we're looking at like activation patterns and, you know, things like that. And so I started then kind of hanging out with engineers a lot because I was like, okay, well, then how do we improve how we measure the brain? Like, we have MRI, we have these different tools, but what I'm really interested in is how that happens, not just in a clinic or a lab, but what that looks like in the real world. And so I find myself in an implantable BCI lab, or implantable brain machine interface. So think like Neuralink style at, an Australian company that was in academia at the time. And so I did my postgrad there, and it was just so fascinating to think about the brain, and instead of it as what I was used to as like a whole system, in these like, now thinking like cellular, hundreds of thousands of neurons at a time, which is really fascinating to think about implantable devices, and that's much more for people who might be paralyzed or have sensory issues, but ultimately not where the kind of questions I wanted to ask. But big benefit is I met my co-founder there, which is like very life-changing friendship. Yeah, we would have met in undergrad at a salsa dancing class, which we went to a very engineering heavy school. So it's like a lot of like, awkward engineers dancing in groups. It was like a very strange situation. Nobody really knows what to talk about and how to make eye contact when you're dancing with strangers. But
Oh my gosh.
it was so funny. But he heard me talking some poor guy's ear off about the intersection of neuroscience and technology and how it was going to like change the world. And this guy's just like eyes glazed over. He's like, whatever, crazy girl. And then my co-founder was like, I'm interested in this. I want to chat. Can we swap dance partners? And so we swapped and like started talking about neurotechnology and what was possible. And within a few weeks, we'd started building different things. And that lab I mentioned, the implantable BCI lab, we actually there were two spots available for that lab for a postgrad, and we got both of them. So we got to start working together there, became best friends, and started thinking about the space a lot. And so, yeah, after doing invasive devices, we were like, okay, look, it was an incredible sort of foundation of understanding at a really granular level how we might stimulate and measure the brain. But the kind of things we want to do, the kind of problems we care about are going to be where non-invasive technology works. So yeah, it was kind of like, okay, we need better tools to measure the brain. Cool, I'm working in measurement tech, measure and stimulate. But really granular. And then we're like, no, well, the things I care about, mental health, understanding the brain from a systems level, we're going to need to zoom out again and measure the brain and stimulate the brain non-invasively as a whole system. And so, yeah, did that. Damien and I decided let's do non-invasive stuff. And yeah, I'm like within a couple months of finishing that postgrad, we were like, all right, let's do it. And so, yeah.
That's awesome. The something I was curious about is the education systems in US versus Australia are slightly different. So what does the postgrad look like? Like when you say neuroscientist in Australia, like what does that mean? Because like US, it usually means you have a PhD or did a dissertation and things like that.
Mhm,
Like
mhm.
what does that look like in Australia?
So, I mean, lots of neuroscientists here also have PhDs. I do not. I left my PhD. So basically, I did an undergrad degree is your like traditional undergrad. I think it's the same in the US and Australia. Then we have this process where to do a PhD, there's two ways to get there. One is do a master's. The other is like a fast track system. It's called an honors. And basically it's kind of like doing a master's in 1 year. You publish a thesis. If you get what's called a class one, which is like the top set of grades, then you get a scholarship to do a PhD. And so when I talk
Wow.
about my postgrad, what that is my honors year where we did a year. So you have to basically, you find a supervisor similar to a PhD, you design what you're going to do. They're like, we need this research done, build a project out of it, write a thesis about it, see if you get the top grades. Obviously, everyone in there is gunning for the PhD scholarships. And
Yeah.
so I got my first class honors for the PhD scholarship, which is great after I did my thesis, which I did on the first neural recordings of that implantable BCI, which is really cool. There's some papers published on it. I luckily got to actually publish some papers from my honors year. And then I went to sit down with actually, maybe this would have been helpful to share as part of my story, but I went to sit down with my supervisor who had gotten to know me a little bit over the time of my undergrad and then also my honors. And he was like, Nat, are you sure you want to do this PhD? And I was like, yeah, like I just worked my ass off for like a year to get these grades, to get this thing. And he was like, well, I don't know. I've gotten to know you over this time, and you are like quite an intense person, and you are constantly pushing to move faster and getting like the head of biomedical engineering to work with me to do these like complex projects, multidisciplinary. He's like, that's amazing. That's great. But like you are so driven and you want to move so fast that you might get like frustrated in academia. Like the next 4 years are going to be like slow. And I just felt like he's like, you're always like, I was probably driving him nuts, like pushing him, like, let's move faster. Let's do this. What about we collaborate here? Let's jump on that project. He's like, I'm just chilling. I chose academia for a reason. And so he was like, if you were my daughter, I would recommend that you like, go work in industry or do something where it's much faster paced because you are just,
Wow.
you have this energy and you want to like move at a pace that I think doesn't necessarily match academia. So unless your dream is to be a professor, don't do a PhD, go work somewhere else, go do something. And so I did get a job at a bionics company, very short stint, because, within a couple of months of working there, I was like, ding, I want to build Neurode. So
Nice.
yeah.
That's it's interesting that that's a piece of your story, because I had an advisor that said the exact same thing to me. Like he was my neuroscience advisor. He was a Northwestern neuroscientist. He's like, dude, don't do this. Like, you need to get out in industry. Like, you're always talking about building a human AI operating system and neurotechnology and all this stuff. Like, you need to go start a company. And I'm like, huh, okay. So it's cool that that's a piece of your story. Like, I wish more people did that. Advisors did that. Like, how do you think your life would be different if you had done a PhD?
Oh my gosh. I don't know. He was like, you're going to die. Like, your energy is going to die here. It's funny because, like, as much as I love the free work for the next 4 years. No, I think you're right. I wish more supervisors said what they actually thought was the best thing for their students to do. I'm really lucky that I had like built a really strong relationship with my supervisor. Yeah, and it's crazy because, at the same time that I had him being like, go out there, do something. This is so exciting. I also had a lot of professors being like, this isn't going to work. This is crazy. Don't go start a company. Stay in academia. It's safe here. So I definitely get to experience both sides, and I'm so glad that I listened to going out there because I think like it's such a different life. I think I would have always wondered like, what if I didn't, and I cannot live like that. So yeah, no regrets.
That's awesome.
I don't know, what do you think your life would have been like if you stayed in academia?
Terrible. I mean, I don't know. There are times where I'm like, I would love to have letters behind my name because it'd be easier. But then there's other times where I'm just like, I want to bring stuff into the world. I want to help people. I'm a better translator of advanced things that researchers are doing and turning it into things people can use in their day-to-day lives, whether it's mental, emotional, physical, like technological things. Like, I believe that's my purpose.
Totally. I think like the credibility that comes from a PhD is obviously enticing. I think that when
Right.
it's really just 4 years working on project and learning a lot about a space. And so you can, especially now with like the internet and AI and everything, like you can learn so much. I think if you're happy to have the knowledge without the title, then you can learn probably as much outside of a PhD as you can in it. Yeah.
Well, and
Yeah, I'm
probably
glad I
more,
didn't
in
do
my
that.
opinion. I mean, most of the people I look up to in history are generalists, like Thomas Edison, Da Vinci, like Elon, like all of these people are generalists, and they bring together all of these different things to like create their innovation or whatever, So it's like, is Elon the best engineer? Maybe not, but he has like all of these other things he brings in, right? And so I don't think there's something to be said for generalists.
Or like having that, people talk about like the T-shaped skill set where it's like you need to be able to be like wide across a lot of things and then deep on one thing. And I think that like building the T of the top of the T is pretty valuable, especially because it allows you to come up with new ideas. Like I think people with ADHD have this like superpower of being able to put things that don't necessarily go together and come up with new ideas. But the more surface area you have for understanding different industries and having seen more things, whether that's like engineering, physics, neuroscience, social, just anything, the more surface area you have, the more like input and tentacles and for ideas you have. And then you can come up with more and more new and novel and exciting things. Whereas if you only ever experience one very narrow window of the world, you're really limiting your ability to come up with new ideas, but also just like limiting your experience of the world. I feel like the more that I learn about other fields and other things, like the richer my life is, and the more sort of like flavor I can add to the way that I perceive new ideas.
Hell yeah. Couldn't agree more. Flavor. I use flavors all the time. What's the wildest like ADHD, like on your T, the wideness of it? What's the wildest, most esoteric, like hyperfixation that you've had, or you've gone down a rabbit hole on?
So many things, like everything from like I learned how to reupholster furniture, like random, through to like I got a
Dude, you
staple
and
gun and
Chloe
that
be
was the
best
end.
friends. Oh my gosh.
100%. And then all the way to like yeah, so like staple furniture, sewing, like all that stuff, through to like I got really, really into philosophy for a while. So many things. Like the spectrum is wide. Um yeah. Why, what's
I'm
yours?
really curious how you learned to manage your ADHD because you've accomplished so much and now you're running your own company. This can be a really hard thing for people with ADHD. Are there any like rules, tools, trips, hacks that you have?
I think I don't know that it's a constant journey, so I don't know that I have like necessarily got everything down pat, but I think the best thing is just a constant sense of like self-awareness and reevaluating and asking yourself like, okay, where am I at? Where do I need to be to do this thing that I want to do? Let's get like creativity is my like knowing my strengths and weaknesses. Creativity is my strength. Okay, I'm gonna find a creative way that I can achieve that goal being who I am. Like instead of I think if I try and like I think there are different things that work for different people. But for me, I think knowing my strengths and weaknesses and knowing what I want and figuring out how I can get there. I think I used to spend a lot of time trying to strengthen my weaknesses in everything in life. I was both like in ADHD and also in like in the way that I try and like I guess I don't know, cope or like manage my ADHD, but also in just like I was like maybe not the best at math and engineering, but I like went into biomed because I was like, I need to strengthen this. Same with neuroscience, but I think now I do a lot more leaning into my strengths. So yeah, I guess where am I now? What do I need to, how would I need to get there? How can I be creative about getting there? How can I instead of kid myself into being like, no, I'm totally gonna be early and start everything early and be on time. Like, no, when do I like how am I gonna if I start where I know I'm gonna really start, how am I gonna get there? And what else? I also like lean on people a lot. So my co-founder is like, I don't know if this is like the most PC thing, but like I feel like every ADHD person needs their autistic like buddy because we have opposite skills. So he's like CTO vibes. He's a physicist and electrical engineer, super brilliant. And we just have opposite like systems and structures and brains. And so we really lean on each other a lot. Like where my weaknesses are his strengths and vice versa. And so like when I get overwhelmed, he has this incredible like process that I don't know, he just like invented for making me feel like I can totally handle any problem. So yeah,
Hell
there's
yeah.
that. Lean on people, know who I am, self-awareness. And like obviously I live by a calendar. Like I've had to build in like tools. Like I live by my calendar. I'm a little bit of an over organizer to try and like compensate. So I have also some compensatory mechanisms as well. And I'm not even gonna lie, like guilt is a great it's a great motivator and fear of failure. There's like, you know, there's
Completely
some
agree
really
with you there.
healthy coping mechanisms and then there's some more just like functional coping
Yeah.
mechanisms.
The high achiever's plight, guilt, shame, and fear. It's like a
I'm
beautiful
lucky I skipped out
neurochemical
of the
cocktail.
shame. Yeah.
Good. That's nice. A lot of people don't
At
miss
least
that
I've
one.
got 2 out of 3.
There you go. I love that. The is there a moment where this creative superpower of yours help you like overcome a challenge or a roadblock or something like that?
Always, constantly. I think it's like my real superpower and probably a lot of our us with ADHD superpower. Not to say that there's heaps of downsides as well, but creativity. Yeah, I think it's these coming up with ideas that other like seeing the world in ways that other people don't or bringing ideas together. Like we're so generative. And I think that's like beneficial to me every day. But even in coming up with the idea for Neurode, like wanting to combine like a type of brain measurement that wasn't traditionally at the time, especially not traditionally used for mental health, with a type of brain stimulation that it was in a completely different field of research within neuroscience. Um, and being like, oh, I feel like this would go really well together because this one needs to be personalized and brain measurement allows you to personalize all these different things. I think, yeah, I think we were I'd venture to say we were the first headband to combine optical imaging and stimulation. And so I think that comes from creativity and seeing things come together that wouldn't normally.
I like that.
I think this is a perfect segue to go into our claim to fame section where we can dive into Neurode a little bit more. So tell us exactly what Neurode is and why we should care in like 60 seconds or less.
Okay, so I have one with me. Neurode is this headband that basically is designed to improve your focus, help you get more work done. And it does that by two things. The first is it measures your brain, so we understand what areas are active and what areas aren't. And then it also uses a type of non-invasive brain stimulation, so these gentle electrical signals to boost and balance brain activity. So our prefrontal cortex, the center of like executive function in our brain, if you struggle with focus, can be underactive. So we want to boost it and balance it using stimulation. And it comes with an app. You wear it for 20 minutes a day while you do work, and it's designed to help you get into work, get into focus, and stay there longer.
Oh yeah. We'll dive into the science way deeper in the lab section here, but real quick, is this, when I was looking at your website, is this like public yet, or is this still in like beta, or like where are you guys at on the development timeline or like process?
Yeah. So it's available for people in the US to purchase and try, but it's technically in a beta. And so that's just like, it's a slightly more involved process where we just check a bunch of things like to make sure it's a good fit for you. So being in the beta basically means that we're iterating the product consistently with you as well. So don't expect things to be as they are the day that you join. 6 months later, the beauty of being in the beta is that every time you tell us something like, oh, this was kind of annoying, we instantly fix it and implement that. So you're kind of co-building the product with us. So while the headband is, obviously ready and manufactured and all nice, and you can see it here, the software and the user experience is being iterated to be designed for you, with you. So yeah, we also check that it's a good fit in terms of like, you don't have epilepsy. We do like quite a lot of extra checks just to be extra safe as we are feeling it out, doing our clinical studies and things like that. So, but otherwise, if you're in the US, you have an iPhone, you can join the beta.
Hey, let's go. Cool. I know Chloe's is stuck somewhere. I don't know. You said is it in Canada, Chloe, or where's it stuck?
FedEx.
Yeah, mine came the day like right after I left, so I'm in Germany right now, and so I'm figuring it out with FedEx, my sister, because I'm like, I need to try this thing.
Yes, let's get it to you. I'm so excited to hear your thoughts.
We've interviewed tons of BCI companies and like neurotech companies. So like if I'm using Mendi, why should I use Neurode instead?
Well, I would say what differentiates Neurode quite a bit is, well, two things. I can't pick one. The first is that we actually have brain stimulation. So where something like Mendi is measuring your brain and it's doing neurofeedback. So it's showing you some indicator of your brain activity, and then you're trying to control a ball and do something. It's kind of you trying to control your own brain activity. Now, well, that can be challenging because you could only do the specific game while you're wearing it. And we just wanted it to integrate into people's work and life. And so we're using an electrical stimulation, a gentle electrical signal to boost brain activity. So there is an active component to Neurode through that stimulation. We're also measuring the brain. And it's something like, as a neuroscience, with a neuroscience background, that's really important to me is really high data quality, because I think that there's so much that's unlocked with data and there's so much ability to provide insights. So where something like Mendi will have a single channel, like one measurement channel in the middle, we actually have 150 sensors across your prefrontal cortex. So that allows us to get this beautiful image of what's actually going on in your brain and to use that information to, one, improve your stimulation, and two, and your experience, and two, provide you insights on your brain activity. So I would say those are the main differences. And I think that we're probably the only wearable headband with this many sensors. So there's high quality of brain data, and the only headband that does combine stimulation and monitoring. So both the sensors and the stim.
Got it. Nice. Yeah.
Cool. Can
Mendi's
you
just
tell us
measuring,
like
I know.
who your customers are? Sorry guys, I might be lagging, but I'll try to throw the question in.
Yeah, go for it.
Can you tell us a little bit more like who, exactly your customers are, your ideal customer is, and then what's your dream outcome for them if everything goes right when they're using it?
Yeah. So our current users are people with ADHD. A lot of them have either a diagnosis or suspect they have ADHD. Some of them don't have a diagnosis and just struggle with focus. Currently, a lot of our beta testers are software engineers, product managers, often in big tech where they have, a lot of pressure to do really well. They're high performers, but they want that extra edge. And also they're kind of ducks swimming in water where it just like you're like, oh, you're a software engineer at Meta, like that's amazing. And they're just like, yes, I'm like doing all the things and I have like so much to do. And they just like they're carrying this backpack of like additional, like at least for me, ADHD can often feel like carrying a backpack with like 20 pounds in it. And then you're just climbing this mountain with your friends and they're just like dee 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 dee, like no backpack or the backpack is lighter and you're trying to climb at the same pace as them and you totally can, but it's so much more exhausting. And so the goal with Neurode is to take like some of the weight out of that backpack so it feels a little bit lighter to climb with all of your peers up that mountain to your goals. And so, yeah, I guess all of our users are people who want to improve their focus, who struggle with it, and who want to and have big goals they want to reach. It really helps when you have that motivator of like, I want to achieve this. I want to be this kind of person. I want to have more to like, I don't want to work, past 5, 6, 7, 8 p.m. every night just to get my work done. So I'm taking time away from my family or my partner or whatever. Or I want to experience deep work for more time so that I can actually like learn this new skill or achieve this goal. And what would I love for those users to experience with Neurode? Well, I think the users that really like fall in love with using Neurode, what I notice is that they, one, use the product frequently, especially at the beginning. So the first week is the most important we find for getting that benefit. So users who use the Neurode 5 times in their first week, they are like, I think 80% more likely to actually experience a benefit. Neurode's one of the things like you got to use it for it to work. Unfortunately, it's not magic in that sense. So, yeah, I think the things that are most impactful for our users are 3 things. One, start work faster. So when you put your Neurode on, the app asks you to say, what are you going to do during your session? So setting that intention helps you actually get started on the task. It forces you to prioritize what do I actually want to do. And then the stimulation helps you actually lock in. Yeah, I think first is procrastinate less, start sooner, and then stay focused for longer are the 2 main benefits. And then quite a few people also say that the chatter in their head kind of quiets down a little bit while they're using their session. So I love that for them. So yeah, I would say those are my dream for our users.
Beautiful. I know plenty of people who could use all of those benefits. Speaking of benefits and claimed benefits and proposed benefits, let's move into the lab section because I have quite a few questions on some of these things. Some on the general science that you guys talk about, and then some on like the research and things like that.
Mm-hmm.
Let's start high level on just the science that you guys talk about. One that I was noticing a ton was ADHD, and you guys mentioned the prefrontal cortex a lot and all the different portions of it. However, a lot of the time, honestly, it was kind of funny because you mentioned the prefrontal cortex so much in your marketing and the stuff that you talk about. But one of the studies you cite on your website is a study that is a meta-analysis of 55 fMRI studies that suggest that ADHD is more of a network issue than it is just in the prefrontal cortex. And so, and a lot of research has supported that, like the basal ganglion, the cerebellum, default mode network, the executive attention network, dopaminergic, like psychology, genetics, culture, ecology, all these different things. So I'm curious what was the decision to focus so heavily on the prefrontal cortex in your marketing and the education that you guys do?
Yeah, I think we do focus a lot on the prefrontal cortex. It doesn't mean that we're, sort of saying, these other networks are not important. We actually look at the brain a lot in using functional connectivity, but we're looking at functional connectivity of prefrontal cortex networks. I think the reason we focus on it so much is because when we were looking at a bunch of studies of the brain on and off of, let's say, medications like Adderall, we see, of course, there's going to be changes in dopamine, norepinephrine, things like that. Really difficult to measure. But what we see as well is upregulation of prefrontal cortex activities. We're like, interesting. Something is happening here in the prefrontal cortex in terms of activation patterns changing when people with ADHD are off versus on medication, for example. And so we started really looking at this area, and it is kind of the home of executive function. And I think that as personally, like I consider myself a pretty high performing person, also have ADHD. I feel like and now as an adult, the most important thing to me when it comes to managing my ADHD is how do I like perform better at work? How do I focus more? How do I manage my executive function? Like these are the things that influence my day to day the most. And so I'm almost less interested all the time in myself as an ADHDer and I have ADHD and these are the things and symptoms. I'm more like, how do I achieve this goal, sit and focus, organize and plan, and like do specific things that are going to help me. And because our working memory, our impulse control, so much of our like attention orientation is all in the prefrontal cortex. That's why we're most interested in that area. It's very like functional. I'm much more interested in like specific symptoms than I am in like necessarily always clustering things into like disorders. I think there's so much variation in the brain, but we do know that the executive function hubs or sort of prefrontal cortex, yes, they are of course influenced by dopamine, norepinephrine, different endorphins for sure, which often get made deeper in the brain, frontostriatal networks and things like that. So yeah, not to exclude the big picture, but just to also simplify. I think in communicating to people, it can be really a bunch easier to go, hey, let's just focus on, first of all, we decided to focus on the prefrontal cortex. That's where the measurement stuff happens. Like as we're measuring your prefrontal cortex, we're seeing these fluctuations. We can see when someone like, I mean, it depends on the amount of data you have in the situation, but you can often see when someone is doing a memory task versus doing a sustained attention task, for example. And so for us, measurement wise, the prefrontal cortex is actually where it's all at. It's where we're most interested in. And then for simplicity in explaining it, I think kind of contrary to the very like medication focused explainer of ADHD, which is all about dopamine, we're it's like a little bit more focused on the frontal networks and patterns and changes in activation and recruitment of these brain areas.
Got it. Okay. So it's just the bet that you're taking essentially, even though research suggests it's like a network, that's the bet that you guys want to take and what you're kind of taking a swing at.
Yeah, so we're not saying that it's not a network or we're not like denying any of the research that's happened. Like totally, it is a network. There's frontostriatal networks, there's dopamine, norepinephrine, all those things absolutely are happening or playing a role. We're just focused on the prefrontal cortex because what we're trying to do is around like focus, sustained attention. When during a sustained attention task, we see parts of the prefrontal cortex light up when you're doing a good job at that. Working memory, impulse control, your inferior frontal gyrus, it's like often lighting up when you're successfully controlling your impulses. We're much more focused on specific executive functions. So like the Neurode does not like, by the way, we're not like FDA cleared, so we're not necessarily claiming to treat ADHD, i.e. completely abolish any like frontostriatal dopamine, all those things. We're just saying we're going to help you improve your focus. We're going to help you start your work. We're going to help you stay focused for longer. And so these kind of claims are more about like, you can understand why they're like quite focused on the prefrontal cortex. It's like where the parts of the brain for sustained attention, etc., kind of show up in a lot of these studies.
Got it. The other thing that, I mean, no shade, but very much I was just like, what? When I saw this was some of the claims that you make about the membrane potential of individual neurons. And so my real, I mean, holy shit. If an at-home brain stimulation device could alter the membrane potential of an individual neuron, and we knew that for sure, this would be like Nobel Prize winning research. Like this would fundamentally change what we know about like neuroscience psychology, and like this would be kind of wild. So is this like a metaphor for marketing? Or do you have direct biological evidence of this?
Yeah, this is actually comes from completely other researchers. This is not from us. Basically, it came from a few different things. So the proposed mechanism of action of tRNS, which has been proposed by a number of different researchers, is stochastic resonance. The idea that adding noise to a system lifts key signals within that system while maintaining the meaning. And so the way that kind of comes through when thinking about it in neuroscience, and I think this also came from some animal studies where they did measurements on, like they did, I don't know exactly right now, but they did mice studies and things like that. So essentially, we do not know for sure. These is hypothesized by different researchers in the field who have been studying brain stimulation over the last, like, let's say 40 years, that have come up with these hypotheses. So this is not fact. We're not like 100% this is what's happening. This is the best that the field has come up with at the time, as of right now, for the mechanism of action of tRNS. And we're like, you know what? If this is the consensus in the field, it makes sense to us. This is how we'll explain it. But just like is true with a lot of medications, like for example, we don't fully understand how Adderall and Ritalin work, but we measure that they do. And so the proposed hypothesis is like, is it completely norepinephrine and dopamine, or is it more dopamine than norepinephrine? We don't know. but it works. And so I think with TRNS, this is kind of the best that the researchers in the field have come up with as the hypothesis of how it works right now. But hopefully we'll be able to either, with more and more data and more brain measurement and more research in this field, be able to confirm that this is how it's working, or come up with better hypotheses for how it's working as we get more real world data.
I mean, I've looked at some of this data and I've seen some of this stuff, and some of this hypothesis, from my read, it's been hard to replicate some of the things that they're talking about in relation to this. The other question that I have, because we see this a lot, we see this all the time in red light therapy space, is this borrowed science or composition fallacy, where a clinical grade near infrared sauna that is 1,000 times stronger than some consumer grade red light thing, that's not equal necessarily, right? And so these red light people will claim the benefits and none of the downsides of clinical grade, medical grade, sometimes 2 or 3,000 or 200 or 300% stronger near infrared or red light, and claim the same benefits.
Totally, I see that all the time.
But that's way to, and it feels semi-similar here, because a lot of the research that you are describing is shifting membrane potential is with skull caps. They're moving hair. It's in a clinical setting, and it actually, I was very impressed. Actually, your stimulation is very close to clinical grade stimulation level. So that's awesome.
It is actually exactly the same as clinical grade, which is really cool.
But still at home, though, is the thing that I was like, that's why it's a claim when on your website it says with Neurode, your membrane potential needs this much versus not, which suggests
By the way, they're not exact numbers. So it's not like we're saying we're specifically doing this difference. It's more just an illustration of the differences. Obviously, nobody could tell you that they're moving your membrane by a specific amount, even if we were doing
dude. That's what I was like, what are we talking about here? Like, how have I not seen someone win a Nobel Prize for this shit yet? So it's more metaphorical necessarily than you guys have used Neurode to directly measure membrane potential in a clinical setting.
No, and so exactly. And so we've never said that that's what we're doing. Essentially what we're trying to do is try to help people understand this membrane potential graph, is try to help people understand the mechanism of action behind it. So that is the proposed mechanism of action. Nobody has measured this being done, whether it's Neurode or anyone else, except, through like composite, either some combination of different studies from different researchers having done a small piece of that pie, each individually, and then ideally replicated it. But what we're trying to do is just explain the mechanism for how it works, so you can think of it as and so yes, if you spoke to like some of the researchers that hypothesize this, they would say, yes, I do believe that what's happening is the membrane potential is changing. Now, how much are we lifting your membrane potential by, et cetera? Impossible to tell, and it's going to be different even per neuron. So we're definitely not saying that specifically we're measuring it from like -50 up to plus, whatever the numbers are. We're not making those kind of claims. We're just saying if you want to get a feel for understanding the best hypothesis we have for how this actually works, this is how we would think about it. And this is how the field is thinking about it. But in terms of stimulation, what makes you interested to know, what makes you think the at-home part would influence, let's say the stimulation hardware is as good and the dosing is as good, dosing, if you will, like the amplitude and waveform, et cetera, is as good as lab-grade devices. What makes you think that the fact that it's at home makes it somehow worse or less effective or something?
Anecdotal experience, but I mean, I could just imagine 3,000. The same reason at the bottom of a bath mat, the suction cup says this side down. Why the fuck do we need to have that as a sticker at the bottom? Because average consumers sometimes they don't understand things as clearly as we think they would. And so I've even struggled with Mendi at times, which is, again, not the same as you guys. And I love it. But if you put it on after you're sweating, if you have hair in front of you, if you put it up a little bit higher and all of a sudden it's more on the top of your head over your sensory motor cortex, or you're upside down, or you're laying in your bed, or you're sitting, or you're doing something, or you don't have any gel with an actual cap that's over your head. You don't have someone that's constantly on your side, watching the actual things. I just feel like there's hundreds of things that could go wrong. Even my freaking device doesn't measure me all the time.
What's really cool is what having a lot of our team having come from research and seeing even in a controlled setting how much can go wrong with repeated placement and things like that. We've done quite a bit to ensure that at home it actually happens where we think. So some of the things we've done is, one, every stimulation session, we do an impedance check to check that the gels are on correctly, that the right dose of stimulation is being delivered, help you access your front camera. We use, remember when Snapchat had all those filters on top of things? Like you could have a dog tongue and
Yeah.
things like that.
Yeah.
Basically, we use Snapchat filter-like recognition to ensure that the headband is on the right position and help you adjust it. So you'll see this when you try it. Let me know how you go. But essentially to make sure that the headband is in the same position every time. We do a lot of mapping and things like that. So we do quite a bit to ensure repeatability and that it's working in real time. So we have a whole onboarding session. Every user does a 15-minute onboarding session with me, shows me how they put the headband on, how we give tips and adjustments and things like that. So we do quite a bit to make sure that the stimulation is repeatable. And of
Oh,
course,
yeah.
as well, the monitoring, the sensors, and that's really important too.
The monitoring was the next question I had.
Yeah.
Because near infrared is awesome. And I think it's cool because I have I test all this shit. I have Muse, all this stuff. I love it. But I'm curious on the decision between EEG over fNIRS, because actually I have two things. fNIRS, the spatial resolution is not awesome, and it's an indirect measurement. It's not measuring neural activity. It's measuring blood flow, which is indirect.
Certainly.
And it's not
So
like
is
it's
MRI.
like looking at an individual, right? Well, it's not an individual neuron. Like you're not stabbing something into a
Totally.
neuron. So why did you go fNIRS?
I actually feel so passionate about fNIRS versus EEG. So I love this question.
Hell yes.
So I don't know. I worked with a lot of different, I worked in implantable BCIs measuring
Right.
actual individual neurons. Such a pain in the
Yeah.
ass. The electromagnetic field changes of neurons is tiny, obviously, and everything else is so much bigger. Like if you look at EEG, so what EEG is trying to do, just like think about it, an individual neuron changes in electromagnetic fields, that's what we're measuring, but composite, because EEG is obviously something you wear on top of the outside of your head. And so we're using these sensors to look at changes in electromagnetic fields, but what else is electromagnetic fields influencing all the time? Well, the muscles in your forehead, as you raise your eyebrows, are like X, what's going on in your brain. Even when you move your eyes to look around, that's going to create signals bigger than that. Your mobile phone, the plugs, the 50 hertz from the thing, this is all influencing it. So by the end of the day, you're looking for a needle in a haystack, and it requires such complex digital signal processing to actually get that out. And by the time you do, it's often very distorted. So while EEG is incredible in lab, I think it's very difficult in the real world to get high quality data, especially because the systems that they use in labs are 64 plus channel systems. Then you can do really interesting things like principal component analysis or independent component analysis to actually see where that signal is coming from. So am I seeing a signal? If I'm measuring here, is that like actually just the composite of the whole area here? If I have enough channels around, I can start to look at where the signal originated from. So EEG struggles in the real world to get any spatial localization. You get amazing temporal resolution, but if you're getting like really noisy data from the real world outside of a lab, very, very difficult to actually gain meaningful information from. Whereas what I love about fNIRS is while it is indirect, it's measuring changes in blood oxygenation. So oxygenated, deoxygenated blood as it moves through your brain, it tells us about brain activity through the principles of neurovascular coupling, which is the idea that in order for your brain, your neurons to activate, they need metabolites to do so. And so blood flows to support that. We're kind of looking at where your blood is flowing, activating as neurons activate, blood flows to feed those neurons the energy that they need to do so. And as other areas deactivate, your brain's like, cool, I don't need to service you with all these metabolites right now. I'm going to go to the place that needs it. And so it actually provides quite a lot of information. It's similar to MRI in that which is kind of the gold standard of non-invasive imaging. Which is also looking at blood oxygen level dependent. So we know this is a good measure of brain activity while indirect. But what fNIRS allows us to do is actually get pretty good spatial localization, better than EEG. So we have 150 channels over your prefrontal cortex, and we're able to measure areas of your brain less than a centimeter apart. This tiny, 150 sensors all over that. So we can make this really beautiful detailed image of what areas are activating and deactivating. That's what actually allows us to tap into brain networks. So you're speaking about like a lot of networks. We do a lot of functional connectivity networks of your prefrontal cortex, and we're able to do that only because of that great spatial localization. It is slower than EEG, so we can't see these little like P300 spikes. We're obviously looking at the speed of blood movement, which is going to be a little slower. But I think, you really make up for it when you can see a detailed spatial resolution. And one more thing I'll say, because I'm such a nerd on this, is because it's light, it's not sensitive to things like eyebrow movements and head movements. So I can be a real person while using this headband. I can like look around, have conversations, emote, and it's not going to take away my ability to read your cortical activity, which it would for EEG. So yeah, that's
Wow.
why we chose EEG.
I love that.
fNIRS.
I mean, I didn't know all
Yeah.
those things. I've
Yeah.
always liked fNIRS as well because some of my early research was in brain inflammation, like glial cells. So astrocytes and microglia are two of my favorite brain cells. But and astrocytes help with like the blood flow you're describing. So I've always enjoyed fNIRS as well. Does this help you? Because another question I have is on the stimulation side, because now understanding how many channels you have and how specific and like you can get with like the map of the brain, to put it in simple terms, that you can get with all of your different fNIRS channels. Does this help with more targeted stimulation or something? Because that's the other question I have is how do you get, like you mentioned, it goes to your prefrontal cortex, but how do you know? You're delivering a general wave of electricity. I don't know how else to describe that. You could probably describe it way better than I could.
How do we know
On the
if we're
surface,
targeting
it
the right
appears
area?
like you're just sending a giant wave of electricity and saying it's going to the prefrontal cortex, but it could be hitting all sorts of stuff in there. Like, how do you know that it's hitting that or not?
Yeah, there's two ways. The first is some pretty awesome simulation software out of a research lab in New York that built this, but I think they built it was, I think, quite a multi-lab effort. Basically, composite a lot of MRI images to map the brain, and then using what we know about like physics and how electricity travels through different mediums, you can simulate the way that stimulation at different doses will travel through the brain, through the tissue of the brain.
Wow.
And so we start with simulations, really like stimulation versus simulation. You start with simulations of stimulation, and then you start doing other things. So yes, we are measuring the brain, something that we aim to do. We don't do it just yet, but we are like at our core a bunch of research nerds. We want to deliver the best like lab grade things in the real world. So we're actually doing some pretty cutting edge stuff. Right now, the stimulation dose that is delivered is much more matching the research papers, like 0.75 milliamps, things like that. And we allow users to tune it themselves. But what we're working on and very excited to at some point have our users use is a personalized dose, where we're actually measuring your brain to understand the response to stimulation, and then helping you and suggesting a dose that is actually causing the desired brain effect. Stimulation usually causes an increase in blood flow in the area, right? After you, I don't know if you've ever used a muscle stimulator, like a TENS device or something, it's often a little red under that area. That's because your blood, like your really gets the blood flowing. And so you should be able to see, for measuring blood flow, we should be able to see the effect of stimulation in the brain. And so as we get more data and as we like sort of improve the algorithm's ability to personalize the dose, we're definitely wanting to be doing that as well. And by the way, stimulation is delivered at 2 points over here. So it goes going in here and in here. And so we are really targeting it at your prefrontal cortex, and it does travel and spread for sure, but it's not, going, through your entire brain. It is pretty localized to your prefrontal cortex, just because, the simulations show that like at some point it dilutes to the point that it's not really going to do, anything over here.
I'm really curious, why 20 minutes? Why not more? Why not less? Is that just something kind of like a trial and error you landed upon, or did that come from former research?
Came from the literature. Well, it was like a little bit of a balance. Like the literature, I guess, has everything from 15 minutes through to an hour. And we were like, where's the balance here between what's going to be like in line with literature, where we've been seeing beneficial effects, but also going to help fit into people's lives, that you're going to, doing this consistently is going to be better than doing it once for an hour. And so we thought, let's start with 20 minutes. It's probably the most common length used in studies. And also it fits into a day pretty easily. But what we found is that often our users will do 2 stim sessions in a day, where they'll do one in the morning, kind of use that focus, and then do one in the afternoon as well. So, there's a lot of safety research on, up to an hour of stimulation, but convenience wise, 20 minutes is seems like the sweet spot.
Cool. Okay, that makes sense. And is there a certain type of work that you think it's more beneficial for, or is it just general any type of work, or are you more like, hey, creative work is better, or maybe like organization and planning, or is this more helpful when you're doing like Excel spreadsheets or something like that?
Yeah, this is where I think like it's really cool to kind of do civic science and like collective community science because
Civic science.
all the research papers have very specific tasks. Doing like a CPT task, which is like press the button every time you see the letter X, to
Mhm,
measure sustained focus or something. These are so boring.
mhm.
While they do in a lab setting help isolate things like impulse control or focus, they just don't represent the real world of like doing a work task. And so we're hearing from our users their favorite task to use Neurode for. So a lot of them will just do their job, like the work that they have to do. Like a lot of them are coders or are founders or things like that. So those are really great tasks. The reason I think they're great is because they require so many different like focus. It requires focus. It requires impulse control. It requires working memory. It requires decision and planning, strategizing. So many different areas of your brain are being activated while doing these tasks. But really, I don't think there's any one specific task that's going to be so much better. I think it's the kind of task that you want to improve your focus at. And also, I also think that like doing a task that requires you to focus is really helpful because it helps you actually feel like notice the benefits. I know if I'm having a conversation, I don't have to think about am I focused because I'm actively being like I'm naturally engaged in this conversation. So we find that our users like feel the biggest benefits when they're doing a task that requires their focus because they're able to go, oh, usually I would really struggle with this. Usually I would struggle to sit down and start a task I don't really want to do, like write emails or plan my day or begin a coding task. Now I can actually notice my benefit. And why that's important is because it's positively reinforcing. So when they notice the benefit from Neurode, they're usually going to do it more often, which is going to compound that benefit for them because it's the kind of thing you need to do to actually feel benefit from. And so I really like to recommend people do things that require focus so that they can notice that improvement in focus so that they will positively reinforce them to continue to one, do focus tasks that's going to help them reach their goals, and two, have Neurode help them. So while Neurode can still help when you're doing slightly less focus requiring tasks, you don't aware of it. And so then it doesn't reinforce that as much.
How do you know it's the device? If I'm wearing a thing on my forehead, I that's got to be a pretty strong placebo. Like, come on. How do you know for sure that it's have you done any I didn't see any clinical trials that you guys have done with your device specifically yet. I saw one coming, which sounds interesting. Maybe you could talk about that. I don't know if you can talk about it yet, but
Yeah, we did do a placebo-controlled trial. We can't share results just yet. We're still analyzing. But we
fair.
also have a study that's hopefully being published soon. We've done the submission, which is looking at the effects of Neurode on improving focus. But some of the, like a lot of the clinical trials that have been done in stimulation use something called sham, which is like a fake stimulation done by the same headband where they just turn on the stimulation so you feel the little tingle, then turn it straight off to look at like a placebo controlled. And so there's been quite a few studies. And by the way, like, there is a placebo effect. But what we're looking for is the effect of stimulation greater, significantly greater than the placebo effect of using a fake headband. And so quite a few studies have shown that stimulation improves focus significantly over and above the placebo. So there's a couple in Nature Neuroscience that I like. One looked at TRNS versus placebo and found that active TRNS significantly improved or reduced ADHD symptoms compared to sham. This was, I don't know, I'm probably going to butcher their name, but Dakwar and Kawa. And
Send it to
also
us and we'll put it in the description. So they're
oh,
that
cool.
the
Yeah, I'll send a
yeah.
bunch of papers. I have like 10 that I really like. That I've done. Another one is this is not on ADHD people, but this is the Cohen Kadosh lab. They did TRNS versus sham and actually saw some really impressive improvements to ADHD in this stimulation group, which is pretty exciting. I'll send it all over.
Again, I love love general research. These are not with neuro devices though, correct? Or are they with your
These are not with
specific
Neurode
device?
devices. This is using the same dose of stimulation that Neurode uses. So basically what we do is we're like, these are not with Neurode devices. These are the exact same type of stimulation, same waveform and same amplitude. So the same dose, if you will, of
Mm-hmm.
stimulation. And so then you can say, well, if it's doing all this, if it's the same stimulation waveform and the same dose of stimulation, we can assume that those are going to be pretty similar. And we've also done bench comparisons of like our device with the lab grade stimulators. There's only a couple that they use in lab, but these are really like quite annoying to use outside of the lab. They've got um like I guess, wires and patches and things, and they use saline, whereas like we use these like gel pads that have the same saline in it but turned into a jelly, which is really nice. So yeah, we've done these lab comparisons between, or bench comparisons between the devices often used in these studies and the Neurode headband, and output is exactly the same. And so because they're exactly the same, we like to extrapolate, but it is an extrapolation of third-party research, not Neurode devices.
The stuff that you guys have coming though is with your actual device, isn't it? Like, don't you
Yes,
have
that's right.
research with your actual device coming soon?
Yes, we do. Very excitingly.
Yeah.
So the one we have
That's
in our beta
impressive.
is the one I'm most excited about. So basically, we have users rate their focus before and after using Neurode while they do their own chosen activity, so like a work activity, and we're able to see a pretty significant improvement. So the average TRNS session improves their focus by 35%. And so we're excited to publish that.
That is one that you can articulate. The with a Neurode, it increases their focus by 35%. Wow. That's cool. I like that. It's hard. I mean, it's these studies. Can you talk about the process of getting research done with your actual device? Because it is not easy. And a lot of companies we talk to are like, we don't have the money, we don't have the funding, we don't have a research partner, we don't know how to. And so it's tough. Could you talk a little bit about what that's like with your actual device and getting that done?
Totally. Yeah. I think, look, it is difficult, but we are a team that is pretty, like, we're a team of researchers as well. So we have done this in academia and like do know how to navigate that sort of ethics or IRB in the US approval process. It is difficult, but basically the way that we do it is we tend to like, there's many different ways to do it. We could obviously partner with university institutions. I love to do that, but it is quite slow. And so another way you can do it is apply to the IRB or ethics body yourself with the study you've designed, as long as it is placebo-controlled, randomized, and blinded, double-blinded. We think that you can get pretty great results. And so basically the process is you design your study. So you read all the literature, you decide what is it that we're trying to understand about our product and its performance, or the system. It's very similar to how you do, I guess, regular research, do a bunch of research, write this whole ethics application up about how you're going to de-identify the data and how, the way you're going to randomize, the way you're going to blind, and the way you're going to test for blinding, and all those different things. You put it all together in a document, you send it off to an IRB. There are IRBs at universities. These are free. These you collaborate with a university partner to do, or you can use a private IRB where you pay for the committee's time to sit and assess it. They might say no, paying for it does not increase your chance of getting approved. You're basically saying, would you please all come together and assess this? They'll come back with feedback.
Could you explain IRB real quick? Institutional Review Board. Could you just tell people what that is? People might not know what that is.
Yes, an IRB is a group of wonderful people, often scientists, people who have studied ethics for human research and the ethics of data and privacy. And it's all about understanding that, is this research safe, first and foremost? Is it ethical? Are we putting people at any risk of, and this isn't just like health risk. This is like data risk. Can their data get out and can that negatively impact them? Privacy risk, all these kinds of things. And then of course, safety risk, we can't be like, what is the risk? And then also, how is that risk that, because everything has some degree of risk, even if very small. And then the question is that risk commensurate with the value and benefit that they could get from participating in this research? And if there is no benefit to them, that needs to be very, very clear to the user. To the participant. And so you're basically mapping out all of the risks and all of the potential benefits to an individual and to the scientific community and society at large, risks on both, and then presenting that to these experts in the field of, it might not be experts in your specific field, but they're researchers in the general field, and then also experts in ethics and safety.
Beautiful.
And you propose what you'd like to do, and they say yes or no, or they usually say no to this, yes to this. If you add this, if you change that, then it's going to be good. And then you do that and then go back to them. It's a really nice, lengthy, bureaucratic process, but it's very important and necessary.
Right. This is how we prevent Stanford Prison Experiment 2.0.
Exactly.
IRB approvals.
Keeping things safe. Yes.
Yeah.
Yes.
Yeah. It's a wild time. Cool. Well, that's awesome. I feel like a lot of people just don't have the funds or resources or knowledge to do that, and with their devices. So it's cool that you guys are on that path. I know it's challenging, and sometimes I fear we come off as if we don't realize that, but we do. But we still got to ask the questions. Another question I need to ask you is
academic
about side
and scientific
effects.
integrity is hugely. important to us.
The other question I wanted to ask was about side effects, downsides. You see a lot of, even in like medical grade versions of what we're describing, like headaches and things like that show up in different neuromodulation type things, but none in Neurode. That is one of those things that feels like it's too good to be true. Could you talk a little bit about that?
Totally. So I guess when we say no side effects, what we're referring to, and like I would say like there's two sides of this. One thing, like almost everything has like a side effect or a consequence, right? Like eating sugar, you can have a crash, whatever. So yes, there are absolutely reports of headaches, fatigue, redness under electrode, which I actually don't think is a side effect. I think that's just a fact. You will have redness under the electrode. It's increased blood flow, but sure, that's one of them as well. The reason why we say no side effects is because in a study on 32,000 stimulation sessions looking at specifically side effects, there was no difference in the reporting of these side effects, like headaches, etc., between fake stimulation or sham placebo and real stimulation. And so it's really, really hard when you're dealing with things like this to know, is the headache, you just have a headache? Is the headache, oh, I'm wearing a thing and it's doing a thing? Or is the headache actually from stimulation? And I think so. It's about 11% of people in both groups report headaches. And so, because of that, we say no side effects. But to be clear, that is just because studies have shown no significant difference. There is still like some chance that actually there is a significant difference. We just didn't measure it in those 30, well, not we, they didn't actually measure it in the 32,000 sessions that they measured. And so, yeah, I would say with 100% confidence, sir, that there's been no serious side effects. And so things like, we call them transient side effects, like the redness that goes away as soon as within a couple of minutes. The headache, if you experience one, often when you take the headband off, it goes away. So, or, within, like most normal headaches do, within a couple hours. So that's kind of how we think about those. But we still report them, and the percentage for all beta testers, we still report all potential side effects and the percentage that they occur in.
And was this a clinical study that you guys did on these side effects for Neurode, or is this general research about stimulation in general?
This is general research. It's actually really cool. Like a bunch of the different stimulation researchers came together, pulled all of their data, and that's how they got the 32,000. So it's like all of the kind of biggest research labs in STEM collaborating. They do a lot of collaboration specifically on safety.
That's cool. Yeah. I love that kind of collaboration. That's cool.
I know. I love when I see all the names from different papers come together, and I'm like, oh, they are all friends. That's so nice.
Something I noticed that you guys might want to edit on your FAQs is it says our most recent clinical study showed no side effects of stimulation. You might want to update that on our to general research or something like that.
Oh, no. Our study did also show that.
So you do have a study on side effects of Neurode.
It's not a study on side effects, it's a study on efficacy, but we also measured side effects in doing so. And so we also, we were able to replicate that finding that in our own study, which we haven't published the results of the full study. We're still analyzing the results, but we have seen, because the side effect questionnaire, very easy to analyze because it's a questionnaire. And rather than all the brain data, we did analyze that and saw no difference in the placebo or sham versus active stimulation side effects. And so that's where that comes from. That is our study.
Got it. Is this 45% of users feel an improvement in 1 week and most start feeling results in 3 to 8 weeks from the study that's not published as well?
No, this is from our beta users. So basically at the end of a week of using the product, we say, have you had that locked in moment yet or not? And they can say yes, not sure, or no. And that's where that comes from.
Got it. Okay. So that one's from like beta users, not like a clinical trial yet.
Not a clinical trial.
But that is tested in this upcoming one as well. So you guys will be able to say that more like definitively.
At what percentage of people feel an improvement by when?
Yeah. That type of data.
We should be able to say that. Yeah.
That's clutch. Damn, that's cool. I love that you guys have. I wish it was live. I wish it was live now. Let us know when this comes out.
I can't wait to publish. Yeah, I'll. By the way, I'm happy for you guys send the preprint of the one that is in the publishing process, because I know you guys won't share it around, and then you'll have it for when it is published. But the clinical study, we haven't even done the write-up yet. We're still finishing analyzing. But the beta research that we've published is all written up. It's been submitted. So if you're interested in like reading it early, I can send it to you. But then I'll definitely keep you posted on when it gets published in the journal.
Cool. Yeah, no, that would be awesome.
Super exciting.
This stuff interests us, and we'll hype it up when it goes. Let us know when it's published, and we'll hype it up. We love when people are doing actual research to back up the claims that they're making. So it's refreshing.
Thanks.
Let's we've kind of been here a little bit, but our skeptical buyer section, which is what we love. Oftentimes people who purchase products from founders or from companies don't get to talk to the founders, but we do. So we like to ask our audience and like look at Reddit, look at feedback, look at reviews, all that kind of stuff, and kind of get some questions. But just off the top of your head, what are some of the biggest criticisms or skepticisms or hesitations that you get from people when they first interact with y'all?
I think the number one is like, is this going to actually work? Like, I understand that it sounds pretty magical. You know, we're also pretty skeptical. Like, we wanted to run the clinical trial as much for us that we ran as it was for you guys, for our users. I think like, you know, we also read everyone else's research, really excited by it, but we wanted to do our own research. So people ask, does it work? And is it going to work for me? And so for that reason, we give a 60-day money back guarantee. So if you buy the Neurode, no questions asked. If it doesn't work for you, just send it back. Like we're pretty confident that it will work. And nothing works for everyone. That's another thing. Like even medication doesn't work for me, for example. Unfortunately, otherwise, you know, well, fortunately or unfortunately, it's the reason I started Neurode. So
Right.
it's fine, but it would be easier if it did work for me. So, you know, nothing works for everybody. And we understand that. And if it doesn't work for you, we're totally happy to take it back. So
Nice.
allow people to actually try it for themselves.
All right. That's badass. Put your money where your mouth is. I like that.
Is there
Exactly.
anybody that shouldn't
use it?
Yeah, is there anybody that shouldn't use it?
Right now, if you have epilepsy, you should not use this headband. If you have any metal implants in the skull, you should not use this. Dental is fine. If you know, obviously electricity, metal, they don't go well together. What else? For our beta, if you are currently pregnant, do not participate. This isn't like a general rule, but this is something we have as a rule at Neurode, is just as an abundance of caution. If you have a pretty severe condition such as schizophrenia, we recommend to not try Neurode. Otherwise, good to go.
Question I have oftentimes, because again, Chloe and I are half science communicators, half like love science ourselves, is the line between research and marketing. And just what is your guys' philosophy on some of these things? Like when you can start to make claims, when you say a certain thing a certain way, like what is just your philosophy on science communication at Neurode, would you say?
I would say it's like, I think about it in two ways. One is like, I want things to be simple enough that people can understand, and so sometimes simplifying something so that they can understand is actually, in my opinion, better than keeping it so complicated that they don't get an understanding. Like, for example, the graph where it's like, we don't know the exact amount that we're improving it, but we're helping you understand the mechanism. Is that going to empower you to make better decisions than it would giving you no information because we don't know unequivocally if something's true? Potentially. I mean, it's the best the field has. And also asking ourselves, like, does this come from us, or is this like pretty consensus in the field? And then when it's pretty consensus in the field, we feel really great doing that. And then when it comes from us, we just like to do things like tell people that it's from us. And the other thing that I think is helpful when it comes to sharing things is like, if it helps you understand the product, if it helps you make good decisions, and then also if there's like a way out, like for example, if we're going to share the information of like, it works for this percentage of people, but then also if it doesn't work for you, you can return it. And like, it's not going to be negative, like a net negative to you. So like you get all your money back and it's like, okay, you wasted like a little bit of your time. So I think having high integrity is just important generally, and being able to build trust. I meet with all of our users, like we do onboarding calls. So I think to myself, like, is this something I would like say to a real person that like, and do I like in good consciousness believe to be true? Can I back that? Do I will I stand by that over time? I think it's not about quick wins. It's about like lasting reputation and rapport with your users. So if I'm going to meet all of you for a 15-minute conversation, I'm going to have to and want to fully back that in our conversation. Do I believe that if I say that we're improving by 35%, are you going to experience that when you come and talk to me after a session and I'm sitting on a Zoom call with you and I'm like, hey, and you're like, about that? I don't want that situation, neither do you. So I think, will I be sitting in front of you having a conversation and feeling really good about everything that I said? Are your expectations going to be when you get the product and you try it? It's in my best, like our interests are aligned, our users, because I want you to get the product and have a really awesome experience and love it and feel good. And if I tell you it's going to be here and it ends up being here, that's not going to happen for you. You're going to be disappointed. And that doesn't work well for either of us. So basically, am I kind of matching what I'm telling people with what they're going to experience so that they come across and go, this is an awesome company. I trust them. I like the product. Good things happen. word of mouth is really like a big thing for startups and for growth, and we really rely on that. Like I think don't quote me on this, but I think the stat right now for us is 68% of our users like refer other users to join, and I think that's
Wow.
because what we say is actually matched with what they experience, and we think that's really important to build trust.
It's like a breath of fresh air chatting with you. The number of fucking companies that just have these TikTok influencers in their basement to just shill out random things that are supposed to help with all sorts of ailments, and you get it, and the expectation just is not met at all. Like it is terrible. The product is nothing like what you think it is why we started this freaking show. And it's just nice to hear that there are companies that and founders that have the mindset that you have. So
It's crazy to me that people are doing that, because like I'm just like, that's your I don't know, this is my face, like this is my,
bro, me
like
too.
I'm
I
putting my
freaking
face
feel
on
you.
this. I'm like, your reputation really matters, I think, because like as a founder, like, and you guys, you know this, like you're taking big risks, and you don't know, like while you're so many things can go wrong in building a company. While the tech could work, the business side could be really difficult, or the business side, like there's so many things that you're doing something that is so complicated and so difficult. The chance of success is slim but amazing and worth it, because you're mission driven. You're like, this needs to exist. Like for you guys, it's like people need to understand more about these scientific products and the science behind them so they can make great decisions, and that like, needs to exist, so you're like motivated by that. But at the same time, like this, it's a challenge. I'm sure there's so many podcasts, how do you stand out, all those things, that you guys are doing an amazing job. For founders and startups, it's really similar. You're like, this needs to exist, we need to like help people, there needs to be more options for people to improve their focus. We stand by that mission, but at the same time there's a lot of chance of failure. There's a lot of startups, and things don't always work out. So the one thing you always have, I believe, is your reputation and your integrity. And so obviously putting my entire life into Neurode to make it work, but if it doesn't, I still have to exist and go out and do a new job and a new thing. And so I do
Yeah.
research and do all the things that I do, and I would never compromise. And I'm surprised anyone would. Like, I'm like, what's the benefit to compromising your integrity? You still got your whole life to live and
I
all
mean,
these relationships and people.
some of these TikTok shop products are just nameless, faceless brands that are just garbage. And then they
Crazy.
hire these influencers to get paid a percentage of sales. And I mean, it's a wild time. So there's not a face in there. Integrity is not at risk. They just get to make money quickly. And so, yeah, it's a AI is going to make it worse. I'm working on a AI therapist. So just imagine how wild that is, and like working with people's mental and emotional health, and like so this is actually the perfect transition into the future. Our last section is talking about the future. What are you guys becoming? What do you see in the future for Neurode and the neurotech space and mental health and emotional health space in general as a founder?
Yeah, I think, wow, there's so much that I'm excited about for the future. Starting with Neurode, sort of helping people who struggle with focus to improve their focus. This is where there might be some kind of deficit. That would be the first mission, right? But then, like, the reason I studied neuroscience, the reason I'm so fascinated by our brain and how it works, I think that we need to understand things in order to improve them. And so we're measuring your brain at the same time. One of our goals is to build the world's largest brain data set, real world brain data set. Because if we only measure the
Ooh.
brain in MRIs where you have to be still, or in lab settings, we're not actually getting a picture of your brain day in and day out, and the variability. What is natural variability of the brain? We don't know. What parts are actually indicative of something going on? Like, oh, that actually is related to ADHD, or actually no, that's just the brain fluctuating day to day. That's going to influence research. Oh, you came in on a good day, you came in on a bad day. So mission number one, improve focus for people with a deficit. While doing so, build the world's largest brain data set so that we can understand more about the brain and ultimately help more. Eventually, I would love for us to be able to do really cool things like improve focus and executive function for everybody. I think as AI evolves, and I'm like a huge fan of AI, but I think as we start advancing artificial intelligence, it's really important that we also have some levers to advance human intelligence so that we can expand and grow with the world and not be too held back. And I think understanding human intelligence is going to also have some kind of relationship with it as we build and understand artificial intelligence. Understanding the brain is like more important now than I think ever. Yeah, I mean, we do a bit of stuff with AI as well. A lot of the things that we do around ensuring repeatability at home, AI helps us do that. So both like the vision stuff and also communicating about headband errors is handled by AI. I would love to do like I think some of the AI therapist stuff is really, really cool. But yeah, I think as we start to understand more about the brain, we can expand not just to focus for people with a deficit and then focus for everybody, but other things as well that contribute to executive function. So I'd be really excited to look at like memory consolidation. I'd be really excited to look at like anxiety and stress and mood. I think there's so much to expand and explore as we start to understand more of these mechanisms.
Is there any like real time stuff you guys are looking at? Like as an example of what I mean, I had a friend of the pod is Dr. Dave Rabin at Apollo Neuro. I don't know. It's this like little like neurostimulation device that I wear all the time, and you wear it during sleep, and it can
Mhm.
sense using biometric data when you're about to wake up and turn on and soothe you back to sleep before you actually wake up. And
Mm.
so I'm curious if there's any, is there any plans to do like, you're about to lose
Totally.
focus and it zaps you?
Yeah.
Zap is such a derogatory word. You know what I
No,
mean?
we're so on the same wavelength. I think so. Right now, it's like you have to go and do your 20-minute session. You're doing
Yeah.
simulation during that. That's like where we're at right now. We imagine like a world where we've made the headband so small, so light, and like, it currently looks like this. So I guess I'll put it on so you can see how
Mm-hmm.
it looks, and I'll tell you a little bit about how I imagine it being. So right now it's like this, but really we want to make it so thin and seamless and light that you can wear it all day and during a work day, basically still look completely like yourself. And be able to turn it, like use the stimulation or the measurement to understand when you're about to have a lapse in focus, and then use stimulation as needed to keep you in this like beautiful flow all day. That would be such a dream. And I think, yeah, we're definitely working on it. We've got our team of engineers always thinking about how we can make the device lighter and smaller. We already have a plan to it weighs 135 grams right now, so less than your iPhone, but we already have a plan to make it 50% thinner than what it is right now. And we're always working towards that goal. Like a dream would be like it's the first thing you put on and the last thing you take off every day because it's so seamless, and it's constantly optimizing you to be your best. That's definitely a very future goal, but something we think a lot about today.
Super cool.
Will you
That's
open source
awesome.
that data, the brain data?
We've thought about this. I mean, we think it could be cool to do like a data sandbox for researchers.
Yes. That would be sick.
Yeah,
I
that would
would
be really
use that
cool.
data. That would be fucking awesome. I want
It would be
more
pretty
people
cool,
to do
yeah.
that, but I
Yeah,
understand.
especially keeping it all
Like,
de-identified and things like that. It's kind of a balance between us wanting to give back to the scientific community and then also being a company and wanting to be like, well,
yes.
we really worked very hard to get all this data and make it happen. But I think there's a kind of a balance. And I think a sandbox, I mean, one day in the future, doing something like a sandbox thing where you get to like come in, play around. You don't get to take the data, but you play with it in a nice environment and then discover findings, and then you can publish them if you're a researcher and things like that. It'd be nice. Let's build that world's largest brain data set first, and then we'll share it.
I'm here for it. Is there something we like to ask everybody? Is there like a strategic partner or somebody in the industry that you'd love to work with, or like a partnership you'd like to form, or anything like a dream partner?
You know what I think would be so cool? Like, how cool would it be if Andrew Huberman did a like Neurode thing? I feel like that'd be so good. I know he does Eight Sleep, which is a really cool. Like he works with the Eight Sleep team, and they do really cool sleep pods. And we share investors with them. So I would love to have Andrew Huberman tried it. I actually DM'd him, and he said he's going to maybe do a podcast episode on different devices. So I don't know if he'll include Neurode. I hope he will.
Bro, that'd be
um,
huge.
it
We've
would be
got
so huge.
do you know who Dr. Ben Wren or Ben Dr. Ben is? He's from Stanford. He does a lot of science communication.
No, but I'll definitely check him out. Like we
I
work
met
with some
him
researchers
on the
at Stanford.
science board of Mendi. And so he loves devices and things like that. That's how he and I got connected. We're interviewing him soon. He's got a book. Well, I don't know. Yeah, he's in pre-launch right now, but I mean, he's there with Huberman. I mean, he's interviewed with Huberman. Like that could be a way in potentially as well. We could chat with him about that, but I
Yeah,
don't know
tell him about
Huberman
Neurode.
myself.
See if he's interested.
Yeah, I will. I think it'll be interesting because we're both interested in Mendi at first because of fNIRS, but you guys are kind of doing both, which I haven't seen either. I don't know if it's the only one, but I haven't seen another. So
Yeah. Also, like, I think I'd be really intrigued to know what kind of data Mendy's getting from a single channel, because I think that for us, like there's so much value that comes out of the 150 channels. Like it's quite like I'd be really intrigued to see if they're getting like a huge amount of very meaningful data from one channel. I
dude,
guess if
the
you're
Dr. I think is it Mufasa? I'm almost positive it's Dr. Mufasa is the neuroscientist that helped start Mendi, and he is a badass. He studies biophysics, neurological biophysics. He is the coolest dude. I'm guarantee he'd be down to chat with you guys if you wanted to talk. He is
Yes,
so
I would
cool.
love to. I would love to chat.
Okay.
We do have some really amazing advisors. I don't know if you know Dr. David Eagleman. He wrote a bunch of different books.
Dude, do I know Dr. David Eagle? Man's a freaking hero of mine.
Yeah, he's one of our advisors
Let's
to
go.
me and the company. And yeah, he's been really incredible in sharing his thoughts on the product and things we can do to improve it. And yeah, he's really great. So I know
That's
he's also at
badass.
Stanford. So maybe they're all friends. I don't know. I have this like weld in my head where I'm like, they're all friends. They're all at Stanford and they're having a great time talking about the brain all day.
Dude, Dr. Ben
But yeah,
and Dr. Engelman they've done shows and podcasts and stuff together, but I can connect you guys.
please do.
Mendi
Thank
slash
you.
Natalie. Cool. All right, I
Oh,
love
the
that.
other person, just can I answer one more thing that you were going to say? The other person I would love to try Neurode is Paris Hilton because it talks about ADHD. She has a song about it. She's like, so cool. The millennial in me, the 90s baby in me is like, yes. I
Yes,
don't know if
that
you
was so
saw,
cool.
yeah. I bedazzled one of the Neurode headbands in pink rhinestones for fun. And I was like, she'd love this.
Oh my goodness. I
That's
missed the
awesome.
pic.
Yeah.
That's awesome.
Yeah. So Andrew Huberman, Paris Hilton, opposite sides of the spectrum, like, science bro, and like that's hot, but somehow it's perfect.
Oh boy. We have arrived towards the end of the podcast, ladies and gentlemen. The lightning lab is our last section though, that we go in. We have a couple questions really quick. Chloe, you want to kick us off here?
Yeah, sure. What is one question you wish people would ask you more?
I don't know. I don't know. Question I wish they'd ask me more
Mhm.
is
Can be about anything. Doesn't have to be about the company.
I don't know. I wish people would just ask me more about like the future of neurotech. I like all the like sci-fi books about how like AI and neurotech help us advance the society. So no, I wish people would nerd out with me more on that stuff.
Have you read Nexus, the Nexus series?
No, is it good?
Is it good? It is like fundamentally where I think we're going. What's your take on techno-humanism, post-humanism, like these types of things?
Like I am currently watching Pantheon, which I think is really interesting. Have you seen it?
I have not seen that. I'm writing it down now.
Okay, it's so good. It's really good. I'd also really liked Permutation City, which is a
Okay,
book about
nice.
how you can upload your consciousness one day so that we can like, I guess the original reason we did it was to stay connected to our friends and family after we pass, but then it has all these like ethical things and implications on society. I think that human technology or human brain computer interfaces, human computer interfaces, I think they're really exciting. And anything that we can do to like expand the way that we get to experience the world and ourselves, I think is like most likely net positive. But I like who knows? Like I guess I'm a big fan of the sci-fi stuff. So I know that there's probably a whole bunch of people who are pretty anti, but I'm pro the merge.
Dude, I'm with you. I'm with you. I'm a techno-humanist and I get
Let's
so
do
much
it.
shit for it, but I don't care. Like I'll be the first cyborg. I don't care.
Yeah,
Like
same. I'm
let's
just
do
like,
this
plug me
thing.
in, dude.
I want it. I literally have a published 200-year vision because I am so confident that this will be possible in our lifetime. Screw it. Let's do this thing.
Let's do
So
it.
that's cool.
Yeah.
All right. Well, if you ever want to nerd out about it,
Or maybe not. What?
that was good. That was good. That was some good science humor. That's a rare find. That was a good one.
The fact that you think that's good science here, we're on the same time.
That was great, dude. I'm genuinely surprised like that. So that was awesome. Last question that we ask. So we always ask every guest we ask to leave a question for the next guest, kind of like Diary of a CEO. And so the question that was left for you was from Rowena, Dr. Rowena Gates. She's from NanoV, and she asked you, what are you doing that will be most beneficial to other and humanity as a whole?
Well, it's hard to know if the stimulation and helping people improve their focus is going to be more beneficial or actually like enabling people to understand the brain in the real world. But I think being like a brain data nerd, I think that for our users, the most impactful thing is the stimulation because that's what's helping them right now today. I think that like something that fits into sort of like this vision for the future of the world and neurotech and the way humans interact with technology that might be really impactful is probably the world's largest brain data set side of things, and actually advancing our understanding of how the brain looks at a day-to-day sort of cadence in pretty high detail would be really impactful for enabling the kind of really cool features we want to enable. So today for our users, stimulation to improve executive function, in the long run, improving our understanding and advancing our understanding of the brain so we can do really cool stuff.
Honestly, that's a great answer.
Awesome.
What's the one that you'd like to leave for the next guest?
What is something that you now know through thanks to your like life journey and experience? I'm assuming they're like building a company or doing something like that you wish that other people who want to start doing what you're doing would know, but like non-obvious things. Like what's the like least expected, most impactful learning that they've had?
All right, what's yours?
I think I have to answer it. No.
We're ready for it.
Yeah. What's mine? I think so many things. I think the most unexpected lesson for building a company, I think it's that like it's been really, really difficult because a lot of when you're doing something that's pretty new, it makes sense in a lot of areas of your life to listen to consensus advice. Like it's generally a pretty good idea to like study hard and do well in school. Like most consensus advice is true for most things in life. When you're doing something that has a really high failure rate and the average person wouldn't succeed, advice that works on averages generally will not work for like this very niche, small, and very rare thing that you're trying, like rare chance of success or rare occurrence events. And so I think the unexpected thing is like the way that general advice, that things that are generally true are not here. And so I think that was something I had to learn is like, I just can't listen to all the platitudes on advice that most people have, and knowing where to take advice from and being really, really selective with the things that you listen to from other people, like what those are and who you take advice from is really tough because like the thing that makes sense often doesn't make sense here. And the average outcome is failure. And so I think listening to most people's advice isn't helpful, and you have to do a lot of like first principles thinking, or just I think like one of the main things that comes to mind for this is like when I started Neurode, I went and talked to a lot of my neuroscience professors and I was like, I want to do this thing. And they were like, don't. Like, that's a pretty bad idea. I don't think you should do that. And I don't think it's going to work. And that like is probably true. But I had to kind of like ignore that and do it anyway because I really believed in it, and I like my want to help people and I help myself as a person whose meds don't work for was greater than like my fear of it not working out. And at this really cool moment where that same professor like came back to me and he was like, I'm so glad you didn't listen to me. Which is really
That was
cool.
amazing. Yeah.
So I think it's just like as corny as it is, like having a lot of like self-belief, and it's something that I'm always like working on. But knowing what advice to and not to listen to, trusting yourself is the thing I wish I had known earlier, to save myself a lot of rumination.
Yeah, that's tough. That's a must-have founder mentality, I feel like. It reminds me of one of my favorite quotes of the unreasonable person adapts himself to the world. The unreasonable person bends the world to their will. Therefore, all progress depends on the unreasonable person. And I feel like you have to have that like mindset to be like, no, Mr. Neuroscience Professor dude, I'm going to do this anyways. So
100%.
That's badass.
I love that. Thanks.
For sure. Well, thank you so much for hopping on with us. This is awesome. I honestly came into this conversation thinking there are so many questions that I have about this device, but I really, really was impressed, and I appreciate you hopping on with us.
Thank you so much. And hey, if I didn't get to answer anything that's still like on your mind, email me or text me about it. I'll send over the papers. It's been so much fun hanging out with you guys. Thanks for having me on. Chloe, I'm so excited for you to get your headband, for you to try it, for you to like let me know how you go. And you've got my number. Just text me. I onboard every person for 15 minutes. So we'll catch up again on onboarding. And I can answer any other questions you have. And just like so keen to hear how it goes, how it's for you.
Perfect. Amazing. I can't wait. Thank you so much. And thank you for taking the time with us today. That was awesome. Great conversation.
Thanks so much. Loved
Thanks,
it.
everybody. All All right, welcome back, everybody. This is the lab results section. Chloe is
Heyo.
struggling right now. It is 12 a.m. Thank you so much for sticking around with us, Chloe. Appreciate it.
I'm still here. I'm still here.
Yeah, dude,
I'll
you
get my
need a
beauty
Neurode
sleep soon.
right now, bro. Like, so let's talk real quick about your thoughts. Any big picture thoughts on Natalie, on Neurode?
First of all, loved her. I think she was like an awesome personality. She handled your grilling really well.
Yeah,
So
she
it was
did.
it was a really good episode. Really curious about the device. I think it's awesome that they have clinical research results coming soon. And I think the concept is really interesting. The fact that you only have to wear it 20 minutes a day, it's something I would totally try. And for me, like the final verdict is it does need more testing, but they're doing it. So they will have results soon, clinical results really soon.
Right. The depth at which you went and explained how similar they are to what their general research they are citing, I was very impressed by, to be honest, as well. Most
Yeah.
companies that try to pull that vast one on us on the show are using the most ridiculous examples and claiming that their thing is the same. But she was very clear on like how similar their device is to the clinical stuff. The clinical setting is the biggest difference. Like it's not in the clinical setting or whatever, but she talked about that as well. And some of the stuff that they're doing with the beta testing. So I was honestly really impressed. I would try it as well. Like she mentioned, she would send an extra one for me to look at as well. So I'm excited to see what happens when you get one, especially. So I would for sure do it. It does need more testing, but I almost give this one a pass the lab test, which I think would be my first one ever.
Whoa.
I know I know my first one, but I really do, especially
Ladies and
once they get this
gentlemen,
stuff.
we've got a pass.
Dude, we've got to pass especially when they send us the data and some of the trials they're doing. I'm intrigued, and I would definitely buy this for sure. Was there anything you were surprised by, or any lessons you learned?
Yes. My brain is short circuiting though right now. I need one. I need a neuro.
You need one right now, dude. Okay, I'll share mine. Mine, the wildest thing was the number of measurement electrodes or whatever they have. I thought that was so interesting, and how they get within a centimeter of some of these different regions they're claiming. That was one of the biggest things. I was like, how on earth? What is happening? But she explained that so well, and it made so much sense to me. And I was just very intrigued by that, and it's really cool what they've created.
Yeah. I think it's an awesome device. I would absolutely try it. They're in beta testing, so if you want to be a user and if you want personal support, definitely go try the beta testing.
Dude, 100%. This might be something you mentioned in your ADHD accelerator too.
Yeah, definitely. I think it's
Low
really,
key.
really cool technology. And I think it's fairly low risk.
Yeah. I think it's really low risk as well. I mean, I think it's pretty good. It's cool. All right. Well, that's a wrap for Decision Lab. Thank you all for being here. Chloe, thank you for surviving over there in Germany, 12 a.m. Couldn't be me. But hope you enjoyed the lab results and brought you some clarity on whether or not this is worth it. We think it is. We think this one is. And if you like this No BS approach to wellness, be sure to hit the subscribe button. And if you guys have brands or experts that we should talk to next, hit us up on Instagram or YouTube. Drop it in the comments. We love hearing from you guys. Thank you so much. See you next time on Decision Lab. Peace.